So in this video I will start with partial differential equation, and we will try to find a solution, numeric solution, okay, for a partial differential equation. Okay, so there are different type of partial differential equation. So this is the parabolic type, and this is a differential equation that is known as heat equation. Okay, तो हीट इक्वेशन का सल्यूशन हम निकालेंगे जैसे विथ कंप्यूटर प्रोग्राम दैट वी वर राइटिंग टू फाइंड सल्यूशन, न्यूमेरिकल वे ऑफ फाइंडिंग सल्यूशन, दैट वे ओनली वी विल टेक. सो पार्शियल डिफरेंशियल इक्वेशन होता क्या है कि पहले अगर हमारे पास, so earlier we had a function of only one variable, for example f of x. Now what if we have a function of multiple variable f of x comma y and so on. Okay, so partial differential equation is also a differential equation which involves differentials, okay, of the function, multivariable function, with respect to one variable only. Okay, so let's say df by dx, this is a partial differential. Okay, df by dy, so this is derivative of f with respect to x only. Okay, and we are treating y as constant or other variables as constant. Okay, तो जब भी डेरिवेटिव करते हैं हम, पार्शियल डेरिवेटिव, तब हम दूसरे जिस वेरिएबल के रेस्पेक्ट में डेरिवेटिव कर रहे हैं उसको छोड़ के दूसरे सब वेरिएबल को एज कांस्टेंट ट्रीट करते हैं. तो अगर इंट्यूटिवली देखा जाए तो ये बेसिकली एक तरीका है जानने के लिए कि फंक्शन f x के हिसाब से कैसे चेंज हो रहा है, हाउ द फंक्शन f इज इन इवॉल्विंग with respect to x only. Okay, so this is a partial derivative term. Okay, so partial differential equation will contain partial derivative terms. So for example एक easy function लेते हैं which depends on x and t. T is time. Okay, right. So we have x and t, and what is f we will discuss. Okay, so f evolves with respect to x and t. So x is what we know as usual, you know, our position variable, and t is the time which passes by. Okay, so let's say for time t is equals to 0, we got a f of x. Okay, for time t is equals to something else, we might get a different curve, let's say g of x. This curve is f of x and this curve is g of x. Okay, so now I will get a set of curves for the solution to the differential equation, partial differential equation. So if I have a partial differential equation like dou f by dou t is equals to dou square f by dou x square. Okay, so let this be my differential equation. Okay, so what it is saying that the curvature of the function f is nothing but it is going to be the function f's derivative with respect to t. Okay, so function f's derivative with respect to t at any point is nothing but its curvature, right? So if we want to know how the function f changes with respect to time, we have to do the double derivative of the function with respect to x at that point, right? And then of course multiply c. So this is known as the heat equation. Okay. So what is the solution of this differential equation? Solution is nothing but a bunch of ordered pair, okay, f1 of x, t1 and so on, okay, fn comma tn, right? At every time I have a different distribution along x, a function describing different distribution along x, and that is what it is. So this kind of a heat distribution damps down and becomes 0. Okay, so we will try to physically describe the system and then find its solution. So I hope that I have made things clear. So न्यूमेरिकल सॉल्यूशन करने के लिए एक तो हमें पता है कि we have to represent the differential term as difference term. Okay, so we have to treat this as discrete values. ठीक है, तब हम some numerical sense इसको, in some numerical sense we can describe the equation. So equation, what it is saying, let us understand. Okay, so what dou f by dou t is saying? So dou f by dou t is saying you take the function, okay, right, you take the function at some instance, discrete instance, okay, discrete instance of position I and discrete instance of position j. So what dou f by dou t is saying? J plus 1 u of, at the same position, j by k, where k is very small. Okay, so this thing is equal to this thing. Okay, so now I am no longer interested in all values of y, all values of u of x comma t, but now I have a discrete space, okay, where I want to compute u of x comma t. I don't want u of x comma t everywhere, but I want u of x comma t at discrete intervals. So can I plot कौन कौन से discrete locations में होंगे? एक तो हो गए ये, let's suppose this is my time axis, okay, and this is my position axis, x and t. ठीक है, तो एक तो हो गए बाउंड्री कंडीशंस. बाउंड्री कंडीशंस क्या है? टू सॉल्व द डिफरेंशियल इक्वेशन वी शुड नो व्हाट इज, सो इनिशियल कंडीशन वी शुड नो. सम conditions are known as initial condition and some conditions are known as boundary conditions. These are constraints. Okay, तो ये है constraints. These are going to help us find solution. Like in case of ordinary differential equation, constraints क्या थे? For first order differential equation, y of 0 was known or y of x0 was known. For the case of for the case of second order, we have y of x0, okay, as well as y dash x0. So this helped us to determine our solution numerically. Okay, so for partial derivatives, what are our conditions? Few conditions are boundary conditions, like let's suppose this is a hot rod. Okay, fine. So let's suppose this is the hot rod. Of length, let's suppose L, and we want to find how the temperature evolves with time. Let's suppose for 20 seconds. Okay, and what are boundary conditions? What are the temperature? So what is f function here? F is nothing but temperature. So can I know f of L? T0? Yes, these are boundary conditions. So few conditions are boundary conditions, like u for every time instance at position 0. Let's suppose that is 0. So this end is basically cooled, right? This is our boundary. So this is 0 degree Celsius, and this is also 0 degree Celsius, right? So that is equal to u of L comma T. Okay, so what is u? U is nothing but also f of x comma t, just a different name for the same function. Okay, so we can regard it as u because बुक्स में u लिखा है, तो मैं कहीं पर f लिख रहा हूँ और कहीं पर u लिख रहा हूँ, तो there is some confusion. Don't get confused. I am referring to the same function. टेम्परेचर डिस्ट्रीब्यूशन फंक्शन के बारे में ही मैं बात कर रहा हूँ. तो डिस्ट्रीब्यूशन कैसे होगा टेम्परेचर का? तो इनिशियल डिस्ट्रीब्यूशन के ऊपर it will depend. So these are the boundary conditions. These two conditions are boundary conditions, because this is what is defined at boundaries. रॉड के एंड में, बाउंड्रीज में, this is what is the case. Okay, तो अभी initial condition. What are the initial conditions? So I should know for all x at time t is equals to 0 the function u. So what is my initial heat distribution? I should know that, otherwise I cannot solve the differential equation. Fine, so this should be known, and this condition is the initial condition. So u of x comma t 0 is the initial condition. So I know boundary conditions. Yes, I know initial conditions. I got an idea of what dou f by dou t means. Okay, right? So can I go ahead and solve? Let's say we have a heat distribution like this at t is equals to 0, right? The temperature at the middle is highest. So what is this curve? This is u. Okay, temperature in the middle is highest, and at the end temperature are 0. So this is confusing, so I will erase it, because we have to plot it in 3 dimensions, right? 2 dimensions are already occupied, so where can I plot u or f? Okay, so I cannot plot them anywhere, because x-axis is my position and y-axis is my temperature, my time, sorry. So along this axis I have different times, and along this axis I have different positions. Okay, so how do I go about solving? I have another term, that is the second order term in position, d square u by dx square, that is also equal to d square f by dx square. Okay, so what does this mean? This means that I will take the function, I will not play with the time, I will keep the time as it is, right? And I will increase the position. So how do I increase the position? So increment of position is represented by I plus 1. So I have to subtract this u of I comma j. I don't have to play with j, right? And h is the step size, where h tends to 0. Okay, but this is the first derivative that I have written. This is df or du by dx, right? Or that is equals to u dash. But what about u double dash or d square u by dx square? Okay, what does this mean? This means that whatever function I have got, okay, I have to again take that and then again take two instances of that, right, and divide it by h. So I have to take u of I plus 2 comma j minus u of I plus 1 comma j, okay, and I have to subtract this u of I plus 1 comma j plus u of I comma j, and then again step size is h. So the whole thing comes under h square. Okay, so what is that? This is nothing but u of I plus 2 comma j minus 2 times u of I plus 1 comma j plus u I comma j by h square. Okay, so this is nothing but this in the discrete form, right? So I don't write u of x comma t, I write u of I comma j, where I and j changes and j is analogous to t and x is analogous to I. So can I visualize this discrete space? Okay, so let me get rid of this rod because it's a bit clumsy. So this is my x-axis, right? So I can have, so this is also my I coordinates and these are j coordinates. I can start with I is equals to 0, yes, and I can end with I is equals to n minus 1 for n points. Okay, and then I obviously have those points which I am not drawing. ठीक है, तो ये तो सब points है ही. And then for similarly for j is equals to 1. And let's suppose I have a symmetrical distribution of point. I have for j is equals to n minus 1, right? So what do I know? What are the region of knowledge? Okay, I know this. Do I know this? ये तो पता है. What is this? Okay, so within the white box, what is this? This is my initial condition. Okay, and what are this? These are my boundary condition. For every time at x is equals to L and at x is equals to 0, my function has value as 0. Okay, so these two are my boundary conditions. Okay, boundary condition 1, boundary condition 2, because there are two boundaries, right? So these points I know, and these points I have to calculate for. I know u at all this I comma j, right? I don't know for these points. So for these points, how can I calculate? So I'm not going to derive exactly because I have already derived. So if you put this thing, fine. So if you put the whole thing here, whatever is, so you can put the whole, equate the whole thing with this. Maybe I have to make a new slide. If this whole thing is equated with this, okay, this is basically my differential equation. So the differential equation, partial differential equation, du by dou t is equals to c times dou u by dou x squared, dou square u by dou x square. This thing is in the discrete form, this. Okay, this is the continuous form. And this is the discrete form. So how do we go and code this? So we can code this because here you can see. So we can start with j is equals to 0, and we know all these values. Okay, and here we have this term, okay, which is also depending on j. Fine, and this is j plus 1 term, which is for the next row. Okay, so if we have the 0th row known to us, so what I want to say, I know all the element in the 0th row. So I know all the element in 0th row. Okay, let's say this is j is equals to 0. So can I calculate u of I comma j plus 1? This is my I is equals to 0, I is equals to 1. Okay, I is equal to 0. For I is equal to 0, I also know j plus 1, and I know all the value. Because what is this? ये क्या है? ये है मेरा boundary condition 1. Okay, For I is equals to 1 I can start. For I is equal to 1 I should start. For the next point, can I calculate with this equation? Yes, because I know ui comma j. Okay, and I also know the step size k. How far is this, right? So if I know all of that, I should be able to find a solution to my equation, right? So can we start with the notebook? Yes. So for this one, before going to the notebook, I will have to tell you another method to compute the same thing. ठीक है? So the other method says that you don't have to compute that because that becomes inaccurate at times. So you can compute this instead. Instead that you can compute this. 4 times u of ij plus 1, and this is a bit difficult to understand at first, but अगर मैं पूरा समझा दूँ तो you will understand what the difference equation says here. Okay, so the right hand side, left hand side concept is still applicable here. There is some manipulation using which we can obtain this difference equation also. ठीक है, तो ठीक है, तो all the terms here are j plus 1 terms. Okay, j plus 1 terms means term corresponds to the unknown row. So we know one row, we can compute the other row, and then we know the bottom row, then we can compute the top row. This was the philosophy here, but the philosophy here is not directly going to compute row but making equations. So for all points, leaving the boundary points, okay, so for all points, let's say for k plus 1 terms, okay, for this row, for all these points I can have a equation. Okay, what kind of equation is this? Let me go ahead and write a linear equation of the form this. Okay, so do I know u of I comma j plus 1? No, I know u of all I for j, not j plus 1. Okay, u of I plus 1 comma j plus 1, so on कब तक u of I is nothing but n minus 2 comma j plus 1. Okay, all these things are unknown. And what are these things? अगर यहाँ से समझ में नहीं आ रहा है, we can go to this point. If we fix j is equals to 1, or maybe j is equal to 0, okay, let us fix j is equals to 0. We will start with j is equal to 0. What are this y coordinate? Okay, the time coordinates, they are all 1. Okay, so we are talking about this row, j is equals to 0. So this is not I mean j is equals to not 0, I should say. This is j is equals to 1. Okay, so a little bit of confusion here. In writing these points, we are representing it as j plus 1. Okay, so j can assume 0 here, but what I mean is the final result is j is equal to 1. We are talking about the first row. Okay, first row we don't know anything. This ये तो पता था, ये तो initial condition है. All the points are known. So for all these points to be computed, we don't know these points. Okay, so what is this? This point is u of I plus 1. Okay, when I is 0, right? U of I plus 1 comma j plus 1. Okay, and the other points, j plus 1 is remaining constant, fine, and all this value are going to change. Let's say I fix I as 0, right, or I start with I is equal to 1, so I have to replace this 1 over here. Okay, so what is this point? For iteration I can assume different I, right? This is iteration, right? Iteration variable I. So the next point is this. Okay, so these are all points on the first row for j is equal to 0, which are unknown. Okay, and there is a relation to this. You can see the relation is this. It depends on, you know, the value corresponding to the lower row, because it is j here, right? J, if I set j is equal to 0, I will find zeros here. Okay, u of I minus 1 comma 0. So we are talking of the very first row, 0th row, right? The 0th row. So little bit of confusion in terms of indexing, but the whole story क्या है? Whole story है कि we have to write all these points. Okay, we have to write all these points in terms of these points, right? यही तो है whole story, right? So in the process of writing all this point in terms of this point, we have this. We have a equation, system of equations, not a single equation. We have systems of equation जहाँ पर for I, let's say I will start with I is equals to 0. Okay, if I start with I is equals to 0, I'll have, or I can start with I is equal to 1 as well. Okay, I don't necessarily have to start with I is equals to 0. I can start with I is equals to 1. If I start with I is equals to 1, what is going to happen? Okay, I will have a equation. So can I solve this equation for I is equal to 1, j is equal to 0, or write it in a form that is simplified for u of 1 comma 1 u11. Okay, for u11 minus u okay, u21, okay, minus u01. Okay, u01 is our initial condition, fine, and that is equals to ui plus 1 is nothing but I is 1 in this case, u20 plus u00. Okay, so can I replace everything here, right? So I have to replace this with 4 because u11 coefficient is 4, u21 coefficient is -1, okay, and every other thing is 0. This is the first row, right? Similarly, I can fill the second row here. Second row is going to be, you have to take my word for this, but if you solve the equation, you will understand why I have written like this, all zeros, right? So we have to have this as m cross n, and this has to be n cross 1. Okay, so the result of this is nothing but this. We have to compute left hand side also, right? So whatever comes at the left hand side, whatever come at the right hand side is nothing but this known values. So this is the, this is the first row. This is the first row we were talking about, and this is the bottom row element. So we are representing a known element in terms of known element. So it is a bit difficult to understand, but we had a partial differential equation, and now we are solving a system of linear equations. Okay, so that is the whole program I have written. I am not writing the program from scratch. It took me about 1 hour to write it, but the whole story is this: partial differential equation in numerical domain are nothing but equation of multiple variable, right, where each variable represents a solution point in the discrete space, right? That is the whole story. We have a system of linear equation, and in continuous time case we had a differential equation. We have to use Fourier series, we have to predict कि solution क्या हो सकता है, in which form solution can come. We have to substitute all this value on the differential equation, equate the coefficient, and we have to do a lot of things to find out the exact solutions. But here we can do this. So can I directly show you the solution and analyze a bit? So that can be done. ठीक है. So if you want a thorough, writing from scratch kind of a thing, I don't think that is required, क्योंकि मैंने इतने सारे बता चुका हूँ, तो इतने सारे methods I have told, and all this are just used here, right? So if I get 10 or 15 requests, okay, on the comment, I will make a video starting from scratch. So that's not required. Anyways, I can go to command prompt. So let us get started with the notebook. So if it is really difficult to follow my videos, it can be, right? But आप ideas capture कर रहे हो. You don't have to fear about differential equation. These are just linear equation of multiple variables. So there is no need to fear, but you have to study. Okay, theory of partial differential equation you have to study. I will provide all the references कि कौन से जगह से पढ़ना चाहिए, so that you will understand. I follow the advanced engineering mathematics book. This is a good book. Just the sufficient amount of knowledge is there, and then if you follow the book, watch the video, watch more videos, or try to understand things from basics, you will understand. So not much to that. Not much attention is required to that, but we should not worry. Okay, attention should not be on worrying. How do I understand this? So your attention should be on focusing. Okay, your attention should be on your goal, not the worry to how to understand. Your attention should be on understanding. Okay, not on the worry of how to understand. So this is a bit of motivation. But anyway, so what I did is I don't have to import numpy every time, matplotlib. These are the general things. Okay, so this is what is written here, x10. What does this mean? Okay, so it means that we have fixed the time axis as 0. Okay, and for that 0, what is our x values? X values, I am considering that my rod is 1 meter long, okay, 1 unit long, and I want to compute on 100 points. Okay, for 100 points I want to compute what are the solutions. Okay, so therefore I have this array over here. Okay, so okay, right, u of 0 comma t. So I have fixed the the x's as 0, right, and I have the t, which is the boundary condition. Okay, what are these values? These are all zeros. We have fixed the boundary values. So I am computing on 1000 point along time axis, and I am computing along 100 points along x-axis, position axis. Okay, so we will compute in this way. Okay, so ux of 0 is nothing but the initial condition. Okay, how the u function, which depends only on x and time being fixed as 0, ux0, therefore the notation. So this is nothing but 50 np sine function. Okay, so this is a function like this. Okay, sine pi x is nothing but like this. It's like a umbrella, and these are mesh grid function to plot our u of x comma y. Okay, so these are attempts to fill our solution matrix. Ux comma y is our solution matrix. If I have the ux comma y, I have found the solution of differential equation. So but we know that for for x is equals to 0. Okay, so we have discussed why the position comes on the on the right hand side, okay, of the array notation. Okay, so first in our function notation, time used to come second and position used to come first, but in array notation they are changed because of the column row kind of a thing, right? All our positions are distributed along the columns, and all our positions are distributed along the columns, and all our time is distributed along the rows. So therefore time assumes the row argument of the array notation. Okay, and position takes the column argument. So I have fixed the boundary condition 1, and here I have fixed the boundary condition 2, right? So what am I doing now? So for all j, okay, so for all the j means for all, so for all rows, unknown rows, so the first row, the 0th row is known, that is the initial condition. For all unknown rows, I need to compute this. Okay, so I am making a B matrix, okay, which is nothing but a column matrix. This is the logic. Okay, I will not go exploring into the logic very much, but we know for the first I we have discussed why I is equals to 1. Okay, because we are computing not for the boundary conditions, so we don't compute for the 0th position. Okay, these are the boundary conditions, and also we don't compute for the 99th position. Okay, so in range function gives us number starting from 1 to 98, not 99. Okay, so for all this position, what we are going to do, we are forming a B matrix, fine, and we are forming a matrix. A matrix is nothing but the result of this relation. Okay, right? A matrix is nothing but the result of which relation? This relation. Okay, so what is the A matrix? This is the A matrix, this is the B matrix. Okay, is this the B matrix? No, this is the X matrix. In our case, I have written it as X1. This is the B matrix, this is the A matrix. Okay, and all these coefficients are coming from where? From this relation. Fine. So I hope that I have made things clearer, and if not, then you have to be a bit more attentive with your, with your pursuit to know all these things. Okay, I can just make a video for an hour, then I'll get on with my work, but you have to go out and study. I am also making this for myself. Okay, so making videos makes me a better teacher, and it proves that okay, I know something about it. So therefore I make video, and if it is helpful, then do share it with your friends. So, but I also want to say that in this video I am showing you the program from not from the scratch. Okay, I am showing you the program from where I ended it, right? I am showing you the program which I have already written. So it's a bit of guilt for me, but anyways, so what am I trying to do? So you can see how I am filling this -1, 4 and 1 in A matrix. Okay, so I'm just not showing you the program, but also trying to convince that this is what I'm trying to do. So this was so you can see the A matrix here. So you can see that there is a pattern evolving. Okay, -1, 4, -1, -1, 4, -1, and it is shifting rightwards. Okay, so I'll show you the program. In the A matrix, what am I trying to fill with my logic? With my great logic, I'm trying to fill -1, 4 and 1, -1. Okay, and with the B matrix, what am I trying to fill? I'm trying to fill this. What is this? Ux comma y j I plus 1, uxy j comma I minus 1. What are these? These are nothing but I plus 1, I minus 1 terms. So that you can find it here also. I plus 1, I minus 1 terms. So I'm not doing anything great with my logic. And you can see here, A matrix is being filled like this. Okay, so all this index manipulation thing is just to push things to the right side. So I'm not going to write the complete matrix myself, but I will use a for loop where a variable increments, and using that variable I build a logic. So I'm not showing you just like this, I am providing you an explanation for that. Okay, any which ways. What is this? Solution for u of I comma j constant. So solution we have discussed कि we are finding solution किसके लिए? For a row, and for a row j is always constant, right? So how do I find a solution for a system of equation? Basically I multiply with A inverse the B matrix, and then I get the X matrix. Okay, so that is what I am doing here. I am multiplying the A inverse with B, for which I get X matrix, and this solution I am inserting into ux comma y, the solution matrix, and then I plot it. Right? Can we go ahead and plot it? Yes, I wanted to make a small change here. Now it looks better. Now it looks like it should look. Okay, and if I increase it to the time 999, let's suppose 999, what do I have? I have a curve which is symmetric about 0.5, and the value has diminished, right? So I can also do something which I was trying to do, IPython. Okay, so I will quickly fast forward this section, but I will do some kind of a animation. Okay, so So okay, so what I have here, I do have a interactive widget kind of a thing which is provided by IPython widgets. Okay, so time is varying from 0 point to 999 points. Okay, so I hope that you understand these are not units but these are discrete points, right? So how do we calibrate those points with unit of time? That is a point of discussion that I have not considered this for this video, but we are more interested कि profile क्या है solution का, how the solution is evolving. So the solution is symmetric. This is the time is equals to 0 initial heat distribution, and as the time passes, as the time passes, you can find that the curve also symmetrically goes down, right? So the curve also symmetrically goes down. So we have seen how a umbrella shaped curve, ठीक है, जो बीच में बहुत हाई टेम्परेचर है और एंड्स में इट इज़ ज़ीरो टेम्परेचर, how that curve diminishes symmetrically. ठीक है, तो let's suppose we have a bit more funnier curve. ठीक है, तो ऐसे दिख रहा है कुछ वो, तो प्लीज़ डोंट गेट वरीड अबाउट दिस, डिसकंटिन्यूटी है ना. तो वो क्या हो रहा है कि बाउंड्री कंडीशंस में we have some discontinuity here. Okay, that is because you can think like a heated rod suddenly brought into contact with 0 degrees Celsius. Okay, so we will see whether our equations are there for this available for this discontinuity. We will have to see for that, right? But as of now let us assume कि discontinuity है और solution सही है. ठीक है, तो how this is going to evolve? So this is how it is going to evolve. So it is not visible now, it is visible I guess, right? So this is how it is going to evolve. So in between that rod has 0 degrees Celsius. Okay, the mid temperature increases and the edge temperatures go down, right? And they die down eventually. So funny things do happen. Okay, but the method is more applicable to newer application, right? Newer application in the field of machine learning, other AI related fields. Okay, so with this I want to conclude ki I have taught you PDE, okay, partial differential equation. There are other type of PDE. You can look at standard books, look at standard solution, and you can also look at the numerical solution. If you want, we can discuss. Okay, write down on the comment box if you want further discussion regarding the numerical solution of this particular parabolic PDE, or should I take some other PDE, or should I take a make another separate playlist for the theories of PDE. So please do mention in the comment box, right? And do like and share. Okay, thank you. That was it for the video.